Ladies and gentlemen, welcome to the presentation titled Opportunities and Challenges for Mid-Sized Drone Manufacturers by Meadowlark Aircraft Company. My name is Ned Tabat, and I am Meadowlark's Chief Technology Officer. I'll be your narrator today. Greetings from North Dakota. It's an honor to establish a valuable relationship with the Korea Unmanned Vehicle Research Association. Thank you for sharing our vision and giving us the opportunity to discuss the possibility of working together. I'll start by discussing some industry background and opportunity, at least from the U.S. perspective. Unmanned aerial systems, or UAS, use the public airspace and as such are subject to regulatory rules that govern them. In the United States, the Federal Aviation Administration is the regulatory authority. Currently, operations of remote piloted drones are restricted by the FAA rule that limits aircraft weight to 55 pounds and range to within direct unaided visual sight of the pilot. During active military conflicts, rules of engagements override civilian regulatory oversight. Large-scale deployment of first-person view drones in the Russo-Ukrainian war has diverted the industry to building small, attritable drones en masse. Significant market opportunity to produce commercial intermediate-size, long-endurance UAS is present, however, for manufacturing companies focused on this emerging market. A convenient way to group different types of drones is by their maximum takeoff weight. And this categorization was initially proposed by the U.S. Department of Defense and has been adopted by Federal Aviation Administration and shows Group 1 with a max takeoff weight of 20 pounds, 55 pounds for Group 2, 1320 for Group 3, and so on. There is a large gap between the max takeoff weight of a Group 2 and Group 3, so it'd be only fair to start putting some gradation in between. For example, what we have labeled here as Group 2 Plus with an approximate max takeoff weight of about 200 pounds, and similarly a Group 3 Minus for a max takeoff weight of about 500 pounds. Our focus has been to build ISR aircraft, that is intelligence, surveillance, and reconnaissance aircraft, at about 125 pounds that would fit in that 2 Plus category, and also specialty multi-rotor aircraft very close to 55 pounds that just barely is in that Group 2. We have in the planning stage a heavier aircraft still for intermediate distance package delivery at 300 plus pounds. That would be yet larger than the existing ISR plane. As we'll see in subsequent slides, the variety of mid-size aircraft that's becoming available on the market is actually blossoming, and you will see a proliferation of mid-size aircraft. However, as the industry transitions from experimental builds to volume production, an opportunity exists for a company like Meadowlark with a focus on manufacturing to capture a significant portion of this rapidly expanding market segment. We label our approach bespoke production. Using advanced design tools, we will enable mission-optimized aircrafts for each individual client. We'll talk about that on slide 8 coming up. Using modern manufacturing techniques, we capture the economics and quality control benefits of volume manufacturing while maintaining build flexibility. Again, we'll talk in more detail about that. We staff and build capacity for all phases of the production life cycle and offer our services as a la carte basis. For example, white label manufacturing for partner clients who wish to leverage our manufacturing scale with their own proprietary aircraft design. An important use case for Group 2 and 2 Plus type aircraft is package delivery. As you can see in this slide, different shapes and sizes of aircrafts are being built And in many cases, these are vertically integrated companies. That is, they develop their own aircraft as they also provide the delivery service. Meadowlark's approach is somewhat different. We are a B2B manufacturer. We build for clients who are then going to be operating companies. And we also want to leverage our design capability in a bespoke fashion to build an aircraft to the shape and the configuration desired by the client. For example, while everybody else uses same size propellers uniformly placed from the center of mass, we have designed an aircraft here shaped like a lobster for a high-end food delivery company, and to do so and be sure that center of mass and center of lift coincide, we have actually built a variable propeller shapes and designs, as well as different types of arms that go on the aircraft. This is a testament to our fairly complex design software capability for optimizing numerous degrees of freedom in the aircraft design. For the next size up builds, groups 2 plus and 3 minus, the industry is settling in on what's becoming known as the hybrid VTOL configuration. Hybrid as in a combination of both an internal combustion engine as well as electric motors for takeoff and land, while the internal combustion engine is direct driving a propeller for pushing or pulling the aircraft in the horizontal plane, as well as providing onboard electric power through action of an alternator. Our offering in this category is targeted at long endurance ISR missions. We have ample power on board for a broad range of active sensor systems, as well as any edge computing that might be desirable to do in real time AI or machine learning type calculations. In order to optimize the aircraft for a particular client's use case or mission, we take the overall unmanned aerial system and we divide it into 6 onboard subsystems and 3 ground-based subsystems, and we'll optimize the combination of those in order to best achieve the mission that the particular client has in mind. Those 6 subsystems are airframe and control surfaces, propulsion and energy source, control board and avionics, communication links, payload interface, and client payload. And in addition to that, of course, the aircraft needs a communication network, ground station where the remote pilot will be operating, and in urban or densely populated areas, the aircraft also requires an unmanned traffic management system to be operational. From a manufacturing point of view, bespoke is all about managing trade-offs. Every time you add customization or novelty to a production line, you're increasing cost, time, and risk associated to the project. So it's all about managing those adverse outcomes from a customization process. But that can be managed, and that can be managed through some critical enablers that Meadowlark specializing on, for example, automation, controls and metrology on the production line, modularity of design, and then core design that's specifically allows for customization, and then volume production, which then enables control techniques that actually makes variability simpler. The outcomes that one gets from this type of manufacturing control are accurate pricing, predictable delivery, and reliable performance from the completed aircraft. To build outstanding aircrafts that place Meadowlark at the pinnacle of U.S. manufacturers in our market segment, we must first build an organization and a corporate culture that supports such a lofty goal. The approach taken is to be prepared to delight our clients in every phase of aircraft production and operation lifecycle. Meadowlark will organize and staff the company to provide best-in-class design engineering, quality manufacturing, regulatory compliance, and post-sales support. However, we need to begin influencing our supply chain subsystems that we do not build in-house. Currently, we only build the airframe within our manufacturing site. The two subsystems that require significant development for use in midsize UAS are A. Propulsion and B. Avionics. Specific to the latter are the detect and avoid sensors that need to be optimized for that group of aircraft. Given the low volume of midsize aircraft currently in production, it is hard for individual platform integrators such as Meadowlark to develop and manufacture these products and to justify the requisite capital investment. Therefore, the industry needs to collectively agree on standards and technology roadmaps to entice capable component manufacturers to enter this space. It is particularly important to recruit manufacturers that are not part of the traditional UAS ecosystem. Many companies in the Republic of Korea have extensive technical expertise in the critical base technologies needed. Advanced engine motor manufacturing for propulsion subsystems and electrical and electromechanical chips for detect and avoid sensor subsystems. North Dakota has the platform integration and flight test capabilities to provide fast cycles of learning to optimize these subsystems for use in midsize UAS. There's a tremendous opportunity to create joint ventures that could address these unmet needs. Meadowlark Aircraft would be delighted to participate. Ladies and gentlemen, thank you for your attention. I'm sorry that I could not attend the meeting in person. It has been nearly 30 years since I visited the Republic of Korea last. I look forward to establishing a working relationship between KRAUB and Meadowlark Aircraft, and I hope to visit Korea again soon.